The principle of inclusion-exclusion. Problem 1. You'll get to see kind of what type of problems we'll be dealing with in this series as we start the first problem. So it says in a sports club there are 50 members. 30 people go to badminton class, which is a type of sport, while 35 people are signed up for table tennis or ping pong, as you might know it. So the question is, how many people are signed up for both badminton and table tennis? So a lot of people count. And that's not a very efficient and accurate way because first you're counting and thinking one by one. Second, well, there could be overlaps, or you might not count some people. So we are going to draw something called a Venn diagram. So a Venn diagram, as you might have used in, say, English class, this is sometimes also used for, say, comparing and contrasting things. So you might have already be familiar with this. And the truth is, it can also be used very helpfully in math for math problems. So Venn diagrams will be the main method we'll be using in this whole series, and this is the solution that you will have to master. So let's review the problem. In a sports club, there are 50 members, and 30 people out of those 50 members go to badminton class. So for this circle, I'm just going to write bad, not because it's really bad, because it's called badminton class, it's an abbreviation. And 35 people sign up for table tennis. So table tennis is TT, table tennis. So how many people are signed up for both badminton and table tennis? Let's first think about the way that this diagram is being constructed. So this portion shaded in right here in green is the people that only sign up for badminton class. And this section right here are the only people that signed up only for table tennis. In this part, as you may see, these two circles aren't separate. One part of them is overlapping. And this just represents the amount of people that sign up for both sports. So we're trying to find what is the area right here. And since the problem doesn't state anything about some people not going to any sports, we'll just assume that all of those 50 members go to at least one sport. So we know that 30 people go to badminton class, so I'll write a big 30 right here. And that for table tennis, there are 35 people who signed up. So let's first add this. Okay. And we get 65. So does this mean that 65? But this doesn't make sense because 65 is bigger than 50. So how can there be 65 people who signed up for sports when in the sports club in total there were only 50 members? And that's because right here we counted it twice. This part was counted twice because it's one part of each of these circles. So what we're here to do is if we want to find this part, this question mark, we need to subtract this 50 members from 65. And why? Well, that's because this is how much we get if we added up 30 and 35. But if we minus the 50 members that's supposed to be there, we get the the excessive part, the part that was counted twice. And that's 15, which means that 15 is where this question mark is supposed to be. So our final answer for this first problem is 15. So that is just a brief introduction to the principle of exclusion and exclusion. So in problem 2, we will be using Venn diagrams to solve a slightly bit more complicated problem. So let's start reading. In a class there are 30 people, of which is divided into 3 homework categories. One is that they only completed the math homework. One is that they only completed the English homework. And another type is when both types of homework are completed. There are 20 people who completed their English homework, and there are 23 people who completed math homework. So the question is, how many people completed only one type of homework? Now you'll see that the information given and the question are a bit different. And really, this problem is just all about reading comprehension, because a lot of people will get confused. So let's reread this problem and make sure we understand. So we know that in our class there are a total of 30 people, and they are divided into 3 homework categories, which one is so there's 3 homework categories. So first, stopping at the end of this sentence, the second sentence, I want to make sure that you understand that even though it says it's 3 homework categories, we are trying to think about the elements that create these 3 homework categories. So the aspects that create these 3 homework categories. So you might have thinking to say draw something like this, but really that's not needed. And if you are somebody who did that, you'll find that it's just kind of looping in circles and you're not really properly expressing the information. So it's not really 3 circles. It's really 2 circles. And what are each of those 2 circles, you ask? So each of these 2 circles are a type of homework, actually. So I will be making this left circle, English homework, and this right circle, math homework, M and a E. So right here, we know in the total there are 30 people, and okay, we were right here. Now we have to read this third sentence. There are 20 people who completed their English homework. Does this mean that there are only 20 people? That the 20 people only completed their English homework? You might think that. So let's see if that was true, and if there were if the 23 people were the amount of people that only finished their math homework. Let's add these up, and we get 43. But that can't happen because in the class there is only 30 kids. So what does that mean? Well, it means that, at the beginning, I already told you this was a problem of reading comprehension. And in this type of problem, it's really, really important to be analyzing what you're given. So there are 20 people who completed their English homework, which means that in total, there were 20 people that completed their English homework. So this 20, you have to know, is not this part, but this whole circle. Okay. And this 23 also isn't just this part, this portion. It contains this whole circle. So now it looks a bit more easier to solve after it's written Venn diagram form. So we're trying to find how many people completed only one type of homework. So now that we have the information all written down, let's think about how we can solve the problem. So in order to find how many people completed only one type of homework, we need to find first how many people completed both types of homework. So this is actually the hidden question that wasn't given from the problem. And that is a question that will lead us to our final answer. So let's ask ourselves, what is the value of this shared portion right here? So this is now turned into the exact same type of problem, just like problem 1 right here that we just solved. So we first add these two values, 20 plus 23. Then using their sum, we subtract the 30. And this 30 comes from the total of 30 people. And after solving, it will get us the excessive part that was shown here. That was counted twice. So 20 plus 23 equals 43. 43 minus 30 equals 13, which means that in here there are 13 people. And now we subtracted 13 from each of the 20 and 23 to find how many people first only completed English homework, then how many people completed only math homework. So 13 subtracted from 20 is 7, 13 subtracted from 23 is 10. So 10 plus 7, or 7 plus 10, is equal to 17, which means that for the second problem, its final answer is 17 people. And this 7 is the amount of people that only completed their English homework, which is this portion. This 10 is the amount of people that only completed their math homework. And as you can see, the word only is very, very important in this type of problem because it changes the definition of that piece of information completely.